Hi ladies, this is lesson 7.5, and in this lesson we're going to work on rewriting logarithmic expressions. So we already did a little bit about this in the beginning of 7.4, but we have some new properties here. So these are our logarithmic properties. So in these properties we're assuming that b, m, and n are all positive numbers, and b does not equal 1. So if you remember the rules of logarithms, we had log base b of y equals x. And with this, we said that b and y both had to be positive. They're both greater than 0. And b did not equal 1. So the same rules apply for these logarithms here. So a log, using the product property, this first property, the log of base b of mn is equal to log of base b plus log of base b of m plus log of base b of n. The quotient property says that if you're taking the log of base b of some number divided by some other number, some other positive number, it's the same as log base b of m minus log base b of n. And then the last one, the power property, log base b of m to the n power is the same as n times log base b of m. So let's do a few example problems. So here we're going to use properties of logarithms. Now we don't need to do any computations of these logarithms on our calculator because it gives us the estimates here. And so these are the two that we should use. So we should use log base 5 of 4 and log base 5 of 9. So let's rewrite this logarithm, log base 5 of 4/9. That's equal to log base 5 of 4 minus log base 5 of 9. And now we know that log base 5 of 4 is equal to about 0.861, and log base 5 of 9 is equal to about 1.365. So the difference between those two is about negative 0.504. So if it gives you specific logs to use, specific values of these, make sure that you're simplifying it and rewriting it using those specific logarithms. All right, so let's try a second one. In this next one, so that was the quotient property. So let's write that up here. All right, in this next one, we're going to use the product property. So we don't have anything that tells us what log base 5 of 36 is, but we do have something that says what log base 5 of 4 is and log base 5 of 9 is. So log base 5 of 36 is the same as log base 5 of 4 times 9. And we can rewrite that as log base 5 of 4 plus log base 5 of 9. We have an estimate for log base 5 of 4. That's about 0.861. And we have an estimate for log base 5 of 9, which is about 1.365. So if we add those two together, we get approximately 2.226. And that is our answer. All right, now in the last one, we're going to use the power property. So again, we only have estimates for log base 5 of 4 and log base 5 of 9. So we're going to rewrite this log base 5 of 81 as an exponent. So we can write that as log base 5 of 9 squared, because 9 squared is 81. So when we rewrite that using the product property, we have 2 times log base 5 of 9. And again, we know that log base 5 of 9 is approximately 1.365. So we want to take 2 times 1.365. And that gives us about 2.73. All right, try these next few on your own. You can pause the video while you work and then unpause for the solution. You're using these specific logs. So log base 3 of 2, log base 3 of 8. Right, here are your solutions. Now in the first one, there's you can use the product property or the power property, and you get log base 3 of 2 to the second power is 2 times log base 3 of 2, which is approximately 1.2618. Now in the second one, you can use the product property or you can use the power property. If you use the product property, you have log base 3 of 8 times 2, which is log base 3 of 8 plus log base 3 of 2, and that'll give you about 2.5237. Or you can use the power property, and if you use the power property, you end up with log base 3 of 2 to the 4th power, which is the same as 4 times log base 3 of 2, which gives you the same answer. Now it's a little bit off because these logarithms are already rounded answers. So the rounding is just a little bit off, but it's 2.5237 compared to 2.5236, which is pretty close. Again, with rounded answers, they're not going to be perfect. Okay, so using these rules of these properties of logarithms, we're going to look at expanding some of these logarithmic functions. So we're going to still apply the same properties that we just looked at, either the product, the quotient, or the property, or the power properties. So here we're going to expand log base 3 of 7x squared divided by y. So we're taking the log of this whole thing. So first we're going to use the quotient property. And that gives us log base 3 of 7x squared minus log base 3 of y. Now we still have an exponent. So since we still have an exponent here, we're not done yet. We need to still simplify. And secondly, we're still multiplying two things together. Okay, so the next step we're going to take is using the product property. And with this product property, we're going to say log base 3 of 7 plus log base 3 of x squared minus log base 3 of y. Now the reason we had to split up the 7 and the x squared before we moved that 2 in front of the log, before we used the power property, is because only x is being carried to the second power, 7x is not. So we have to split those up before we can use this power property. So we're going to do the power property next. So with the power property, we have log base 3 of 7 plus 2 times log base 3 of x minus log base 3 of y. All right, now let's look at condensing some of these logarithmic functions, expressions. So here we have log, and there's no base indicated, which means it's the common log. Which is the log base 10. Okay, so again, since this is not indicated, since there's no base that's indicated, we're using the common log here. So here we have log, common log of 2 plus 3 times common log of 3 minus common log of 9. So we're going to condense all of these. So this means adding means that we're going to use the product property, because the product property says that log of base b of m times n is the same as log base b of m plus log base b of n. So log of 2 plus 3 times log of 3 is the same as log of 2. Well, actually, you know what? We should do anything that's being raised to a power. Really, we should do that first. So we're going to actually focus on this first. So we're going to look at the power property. So log of 2 plus 3 times the log of 3 is the same as log of 3 to the third power. And then minus log of 9. So let's just simplify this before we go forward. Log of 2 plus log of 27, that's 3 to the third power, minus log of 9. Okay, now we can apply the product and quotient property. So let's do the product property. Next. And here, since we're adding, that is part of the product property. So log of 2 plus log of 7 is the same as log of 2 times 27 minus log of 9. So again, now we're just going to simplify this, which is log of 2 times 27, which is 54, minus log of 9. Right, and then our last step is to use the quotient property. And we know we're using the quotient property because we're subtracting these two. So the quotient property brings this to log of 54 over 9, which again, we can simplify. And 54 divided by 9 is 6. So try these next few on your own. So you're expanding the logarithmic function and then you're condensing the logarithmic function. You can pause the video while you work and then you can unpause for the solution. In this first one, you could do this several different ways. You could start with the quotient property and then do the product property and then do the power property. But the way I have it shown here is first we're using the product property to split up the 7 and the y cubed in the numerator and the 4 and the x squared in the denominator. From there, we're using the power property to get rid of those exponents. So we have log of 7 plus 3 times log of y divided by log of 4 plus 2 times log of x. And then lastly, we're using the quotient property. Now with the quotient property, no matter which order you did this in, you're taking log of 7 plus 3 times log of y minus this entire quantity. You're not just subtracting the log of 4, you're subtracting the log of 4, the sum of the log of 4 plus 2 times the log of x. So if you rewrote this, it would be log of 7 plus 3 log of y minus the log of 4 minus 2 times the log of x. So you have to remember to distribute that negative sign because you're subtracting that whole quantity, log of 4 plus 2 log of x, not just that first term. All right, in this next example, we're condensing. So first I use the power property to get that 2 natural log of x to become natural log of x squared. Then I use the product property to combine the natural log of 3 and the natural log of x squared. And then lastly, I use the quotient property. So my final answer is the natural log of 3x squared divided by the natural log of y. Which actually I can simplify one step further to say that this is the natural log of 3x squared over y. So really this is my final answer. All right, in this next section, we have something that's called the change of base formula. So this is helpful for when you want to use your calculator to evaluate logarithms. So if we have a log with base c of a, that's the same as log of base b of a divided by log of base b of c. Some restrictions are that b cannot be 1 and c cannot be 1. Okay, so neither of your bases, we can't have a log with a base of 1. So we're going to use the change of base formula to evaluate the log base 6 of 11. And we're going to use common logarithms, which again, that's just log, and natural logarithms, which are ln. If you look at your calculator, you have a log button and you have an ln button, a natural log button. And so this is helpful for when you want to use your calculator to evaluate logarithms. No matter what the base is, you can use this change of base formula. So to use the change of base formula to look at log of base 6 of 11, so this would be our c value, and 11 would be our a value. Okay, so let's use this change of base formula. So we're going to look at the natural log, or we're going to look at the common log first, which is just log, we're saying the base here, the base is 10. So the common log of 11 divided by the common log of 6. We can also use the natural log, and it's going to be the same thing. So we can say the natural log of 11 divided by the natural log of 6. And again, these are things that you can do on your calculator. So when you put this into your calculator, you get a rounded answer, and it's approximately 1.338. So try these next two examples on your own. So you're using the change of base formula. You can pause the video while you work and unpause for the solution. So using your calculator to get these rounded answers, log base 16 of 26 is 1.175, and log base 5 of 13 is approximately 1.594. So in the first one, using the change of base formula, you have log of 26 divided by log of 16, or natural log of 26 divided by natural log of 16. And in the second one, you have log of 13 divided by log of 5 is equal to the natural log of 13 over the natural log of 5, and you can calculate either one using either one of those log buttons on your calculator, either the common log or the natural log, and you'll get the same answer. So that's it for this lesson. So please jot down any notes or questions that you have, and we'll go over them in class when I see you. Thank you.